welcome back to Elementary Algebra. I'm your instructor, Amy Fuchsteiner. We are going to be looking at Chapter 9 today. Chapter 9 is all about quadratic equations. These are equations of the form x squared, usually plus bx plus c equals to 0. So the important part about this particular chapter is that we're going to be learning 4 different methods to use in order to solve a quadratic equation. Actually, you already learned 1. So we're going to be learning 3 more. What's going to be important about this particular unit is that you are careful with the instructions, because when we ask for a specific method, we're trying to make sure that you have some understanding and mastery of that particular method. So please make sure to follow the instructions as they are requested of you. All right. So section 1, we're going to learn the square root property. The square root property, I'm pretty sure that you are all already aware of it. The square root property basically says that if you have any non-negative number c, if you know that x squared is equal to c, then when you take the square root of both sides, whoops, that got a little messy there, that x value could be the positive or principal value of c, or it could be the negative value of c. And that most frequently, we write this as a positive negative c. That's known as the double sign notation. So when you have a quadratic equation, that is an equation that starts with an ax squared, usually plus bx plus c is equal to 0. That's the standard form. We have talked about that before. When you go in for the x squared, remember to consider both the positive or principal square root and the negative square root. Let's see that in action. All right, so here we have some sample problems. I'm going to run through some of these using the left side, right side, and solving the equation. I have x squared minus 15 is equal to 0. So I'm going to go ahead and add 15 to both sides of this equation. Again, I may be showing more work, at least in the beginning, and I'll lay off some of these steps as we get further in. So this will be x squared is equal to 15. Then we will take the square root of both sides. So the square root of x squared and the square root of 15. The square root of x squared is x. The square root of 15 is not going to simplify. 15 is not a perfect square. And if I break 15 down, I get a positive 3 and a positive 5, neither of which is a perfect square. So this is just going to be the positive negative square root of 15. So there are technically 2 solutions. It could be the positive square root of 15, or it could be the negative square root of 15. This is known as the exact solution because I have not figured out any of the decimal places. If you are asked to round things to, say, the 100th place, then on the calculator, we would just clear all this out. We would do second square root 15, or find the square root of 15, to get about a 3.87. So if we're going to round it to the 100th place, this would be a positive negative 3.87. Okay, that's what it is to the 100th place. If I'm going to check this answer, I'm going to use the square root of 15 and not the decimal. You can use the decimal. The decimal will get you close. Maybe I'll show you that one. That would be all right. But if I'm going to check this one, I am going to open parentheses, do second square root 15, close parentheses. That closes the parentheses inside. Now I have to close the one that I opened and square that, because I want to square the square root, and minus 15, and I should get 0. And I do. If I need to do this for a negative 15, because we should check both solutions, I am going to scroll over. I'm going to insert a negative. I love this particular function. So now I'm checking the negative square root of 15, and I still get a 0. So I have been able to check both of them. They both check. There we go. And I have that x is equal to, maybe move this over. There we go. X is equal to a positive negative square root of 15. Okay, let's try number 2. Same idea, left side, right side. I'm going to subtract the 18 from both sides this time because in order to use this square root property, we want to isolate that x squared. This gives me x squared is equal to a negative 18. Once that square is isolated, I can come back in and take the square root of x squared, and the square root of a negative 18. Square root of x squared is x. Square root of a negative 18, can we take the square root of a negative number? We cannot take the square root of a negative number. For this algebra course, we are only dealing in real numbers, and the square root of a negative number is imaginary. We have mentioned it before, but we're not going to study imaginary numbers in this particular course, so we will not be taking the square root of a negative number. Our x value does not exist. So there is no solution for us. Right? Because we are only talking about real numbers, we do not have a solution for this particular problem. It happens sometimes with square roots because you can't take the square root of a negative. All right, moving on to number 3. I'm going to add 54 to both sides in order to isolate the square here, which is just the k. So I'm going to add 54 to both sides. That gives me 2k squared is equal to 54. Then I'm going to divide both sides by 2. So I'm going to have k squared is equal to 27. Once I have isolated the squared, I can take the square root. So I will have k is the positive square root of 27 or the negative square root of 27. I have a squared variable here. When I solve it, I can have up to 2 solutions. The exponent tells me the number of solutions I should be looking for. And this clearly says 2, so I should have both a positive and the negative solution. This is often written as a positive negative square root of 27. Now, we do want you to recognize that the square root of 27 can be simplified. That's what we did in chapter 8. So, square root of 27 is 9 times 3. So this would be the square root of 9 times the square root of 3, or 3 square roots of 3. This is my exact answer, which I may need to calculate as a decimal. If I need to calculate it as a decimal, I very simply plug it into a calculator, right? Now, what about checking it? If I want to check this, I want to check the square root of 3, and I want to check the negative square root of 3. So this would be 2 times the square root of 3 squared minus 54. I'm going to use my calculator for that. I have a little bit of a glare. And I'm going to be 2 parentheses square root of 3 squared minus 54. Ooh. Oh, it's 3 square roots of 3. I forgot my 3. You see how I forgot my 3. There we go. All right, so to fix that, I'm going to come up here. I'm going to let it blink over that. I'm going to second insert, just like you would. There we go. 3 square roots of 3. And I get a 0. Okay, so that checks. Now, if I want to check a negative square root of 3, again, I'm going to scroll over the 3. I'm going to second insert. And I'm going to type in a negative, and then I'm going to hit it. And that also worked. So 2 times a negative 3 square roots of 3 squared minus 54 also worked. All right, so I do have 2 solutions. And I have a positive square root 3, and a negative square root 3. Both worked. Okay, problem number 4. Problem number 4. I'm going to add 40 to both sides because I want to isolate the squared part. So 5m squared is equal to 40. I am going to further isolate the m squared by dividing both sides by 5. That's going to leave me with m squared is equal to 8. Now, since I have an m squared equal to 8, I can square root both sides of this equation so that m would be the positive square root of 8 or the negative square root of 8. The square root of 8 does have a perfect square as a factor. I can do 4 times 2. So this would be a positive negative square root of 4, which is 2, times the square root of 2, which is left. For those of you who like to do the factors, this would be the square root of 2 times 2 times 2. So with those pair of 2's, 1, 2 can come outside. This would be our exact answer. And if I needed to, I could then punch that into a calculator to approximate it. If I'm going to check this particular answer, I need to check both the 2 square roots of 2 and the negative 2 square roots of 2. You can do this using solely your calculator. So, can we see it? Okay. So I'm going to do 5 parentheses, 2 second square root 2. I need 1 set of parentheses to close what's underneath the square root, and then a second set of parentheses. So now I need to square that, and that's going to give me 40. When I minus 40, I'm going to get 0. So 40 minus 40 is going to be 0. This guy works. And to check a negative 2 square root of 2, I like this calculator because I can just scroll over, have it blinking where you want to insert it. Second, insert, negative, enter, and I still get a 40 when that's negative. So 40 minus 40 is 0, and that checks. Okay. All right, problem number 5. Left side, right side, I'm going to have a 3y squared plus 4 is equal to 13. So I'm going to subtract 4 from both sides. 3y squared is equal to 9. I'm then going to divide both sides by 3 because the goal is to isolate our squared here. So y squared would be a 3. Now I'm going to take the square root of both sides. So y would be both a positive and a negative square root of 3. Square root of 3 is not going to simplify, but I should check my solutions. So I need to check both a square root of 3 and a negative square root of 3. You can, once again, do this solely by using a calculator. So I'm going to do 3 parentheses, second square root 3, closing what's under the square root, closing the parentheses I opened, and squaring those, plus 4. And my hope is that when I plug all this in, I get a 13. And I do. So a positive 3 works. To check a negative 3, I'm simply going to use my up key, scroll over where I want the negative to be, hit a second insert, negative, enter, and I still get a 13, so the negative 3 checks. So my exact answer is that y could be a positive or negative square root of 3. Okay, what about number 6? Left side, right side. I've got a 6a squared plus 18 is equal to a negative 12. So I'm going to subtract the 18 from both sides. Negative 12 minus 18 more is a negative 30. So I have a 6a squared is equal to a negative 30. Dividing both sides by 6, we have a squared is a negative 5. Taking the square root of both sides, we will get a is a positive negative square root of a negative 5. Can you take the square root of a negative number? You cannot. So this problem, like the other one with the square root of a negative, Oops, I spelled that wrong, but that's okay. You understand I forgot the E, is also a no solution. All right. Those are the basic problems. We're going to kick it up a notch in the second goal, and we are going to have the square root property solving binomials. Oops, there goes my little post-it. We're going to have the square root property solving binomials, ax plus b, quantity squared. See how we got that big thing in the quantity? All right, so this is just a bit. We need to think about things here. So what happens then when we have this ax plus b squared is equal to c? When we take the square root of both sides, this gives us the square and the square root. Those cancel, right? So the square root function and the squared function are inverses of each other. So the square eliminates the power of 2. Square root eliminates the power of 2. So that leaves us with just the ax plus b in parentheses. But because we're solving, that square root of c is either going to be positive or it's going to be negative. So ax plus b is equal to c, or it could be that our ax plus b is equal to the opposite of that c. Oops, square root of c. There we go. Because we should have a positive square root or we should have a negative square root. Here's how that works. Okay, if we're looking at problem number 7, sorry, I need to get my... Here I have x minus 4 squared is equal to a 25. So, left side, right side. I'm going to write this out maybe a little bit more than I normally would because I want to be able to see the original equation. So I'm going to take the square root on both sides here. It's exactly what we want to do. The square and the square root, so the power of 2 and the square root will cancel each other out. They're inverse functions. Underneath here, we will have x minus 4, and that will be equal to, the square root of 25 is 5, but I need to consider the positive and the negative 5. This allows us to break into 2 possibilities. It could be that our x minus 4 is equal to a positive 5, or it could be that our x minus 4 is equal to a negative 5. So because we took the square root and got 2 possible solutions, we have to consider both of them. And that's going to give us 2 little mini solutions. Adding 4 to both sides, we get that x could be 9. In this one, when I add 4 to both sides, I get x is a negative 1. So now I really need to check. So to check the 9, I have a 9 minus 4 squared, or 5 squared, which is 25. So that guy checks. What about checking the negative 1? If I check the negative 1, I have a negative 1 minus 4 squared, which is a negative 5 squared, which is still a 25. So this one also checks. I have 2 solutions. I have the x equal to 9 or the x equal to negative 1. And that makes sense because anytime we had a squared, we have the possibility of 2 solutions. Here I have those 2 solutions. Okay, let's try another one with number 8. I'm going to do the same thing to just kind of show my work more clearly. I have a 3x plus 5, and I'm squaring it equal to 49. This whole side is a square, so it is isolated. I can use the square root property to take the square root on both sides. Okay. On the left side, the square, and the square root are inverse functions. They eliminate each other. So I will have just the 3x plus 5. The square root of 49 is either, well, square root of 49 is 7. But because we're taking the square root in a solving function, it's either a positive 7 or it's a negative 7. So I have two possible solutions. So because it's positive, negative, using the double sign, this splits. And it could be that my 3x plus 5 is equal to 7, or it could be that my, running out of room, 3x plus 5 is equal to a negative 7. So I have two possibilities here. To solve them, I go through the same steps. On this left equation, I'm going to subtract 5. So 3x would be a 2. And then I'm going to divide both sides by 3. X is 2 divided by 3, or 2/3. On the right side, I'm going to go through the same process. I'm going to subtract 5 from both sides. So negative 7 minus 5 more is a negative 12. And then I'm going to divide both sides by 3. 12 divided by 3 is 4. So this is going to be a negative 4. To be sure, I want to check to see if either one of these ends up with a negative under the square root or can be eliminated. So I need to go ahead and check these. If I'm going to check 2/3, this is going to be 3 times 2/3. Whoops. There we go. Plus 5 squared. Okay. So I'm going to do 3 times 2/3 plus 5. Well, this is going to be a 7 squared, which is indeed 49. It checks. 2/3 is a valid solution. And I'm also going to check that negative 4. And if I check that negative 4, I'm going to have 3 times a negative 4 plus 5 squared. That's 3 times a negative 4. That's negative 12. Plus 5 is a negative 7 squared, which is also 49. That checks. So both of them check, and that means that both of these are solutions. X could be 2/3 or X could be 4. Both of these are solutions to my equation. And it works because this is a quadratic, which means second power, which means up to 2 solutions. I don't have to have 2 every time. I could have 0, I could have 1, but 2. I got 2. All right. Let's look at problem number 9. Problem number 9, same idea. Again, I'm probably writing out more work than some of you will. That's perfectly fine. So this is going to be x plus 3 squared is equal to 63. I'm going to take the square root on both sides. Okay, once again, I can go straight to the square root because there is nothing else on this side except this squared binomial. If it was like a plus 7 or something, I'd have to move stuff around. But this is just a straight up. Now, the square root and the squared are inverse functions of each other. They will eliminate each other, leaving us with just x plus 3 on this side equal to the square root of 63. Square root of 63. Well, 63 is 9 times 7. So this is going to be the square root of 9 times the square. Okay. So this is going to be plus or minus 3 square roots of 7. Okay. Now, because it's plus or minus, I end up with 2 equations. In the first option, well, yeah, let's do that. I have x plus 3 is equal to 3 times the square root of 7. In the second option, I have x plus 3 is equal to a negative 3 square root of 7. Okay. Some of you will really like this. Some of you will not. Here's the thing. Because this is an exact answer, I don't want to figure out what 3 square roots of 7 is as a decimal. I don't need to. So they're not asking me to round to hundredths. They're not asking for an approximation. So I am not going to figure out what 3 square roots of 7 is. I'm just going to leave it 3 square roots of 7. like if it was 3 x's or 3 socks or 3 inches. I'm just going to leave it as 3 square roots of 7. But I will need to subtract 3 from both sides. So this x would be equal to, word of caution, you have a 3 here and you're subtracting 3 more, but these are not the same 3's. This 3 is attached to a square root of 7, so these won't cancel. The only way to eliminate this 3 is if we're dividing, and we're not dividing, we're subtracting. So we would rewrite this as negative 3 plus 3 square roots of 7. I know many of you won't like this, but that is what it is. It is a negative 3 plus 3 square roots of 7. The second x value is the same setup. See how it's x plus just a 3 is equal to a negative 3 times the square root of 7? I'm going to isolate the x by subtracting a 3. And again, if I subtract it on this side, I need to subtract it on the right side. They're not the same 3's. This 3 is multiplied by the square root of 7. The only way to cancel out that multiplication is to divide. We're not dividing, we're subtracting. So this would be x equal to that negative 3 minus 3 square roots of 7. Okay, I still have 2 answers. I have a negative 3 plus 3 square roots of 7, and I have a negative 3 minus 3 square roots of 7. So I still end up with 2 solutions. Now, I need to check them. Checking these guys, that's why we like our calculators, right? So if we're going to check this, we're going to do a square root. We're going to do parentheses. And then we're going to do negative 3 plus 3 square roots of 7 plus 3 squared. Oh, do you see what happens? I've got a negative 3 plus 3 square roots of 7, and then I've got a minus 3. So inside the parentheses, my negative 3 and my plus 3 are going to cancel out. And I've got a 3 square roots of 7 squared. So if I do 3 second square root 7, clearing parentheses, 3 second square root 7, close the parentheses for the square root, close the other parentheses, and I square it. I bet I get a 63. And I did. Okay, so this one does check. This is a valid solution, negative 3 plus 3 square roots of 7. We're going to do the same thing over here. We're going to check this one. So inside my parentheses, I would have for my x a negative 3 minus 3 square roots of 7. But then I need to add 3 to it, and then I'm going to square it. That negative 3 and that positive 3 will again cancel out, leaving me with a negative 3 square root of 7 squared. And that's going to be 9 times 7, which is going to give us 63. And again, that one checks. So I have my 2 solutions. Okay. I have a negative 3 plus 3 square roots of 7 or a negative 3 minus 3 square roots of 7. That kind of makes sense because one is plus and one is minus. Yeah. Oh, I'll show you with this next one. Okay. So, same problem. It's not the same problem. It's the same type of problem. 2y minus 3 squared is equal to a 48. I'm going to take the square root on both sides. So the squared and the square root are going to cancel each other out, leaving what's underneath 2y minus 3 is equal to the positive negative square root of 48. 48, that's going to be the square root of 2 times 24, which is 2 times 12, which is 2 times 6, which is 2 times 3. So pulling out my pairs, that can come out. That second 2 can come out, and I have a square root of 3, so this is 4 square roots of 3. Okay. So 2y minus 3 is a plus or minus 4 square root of 3. Okay, I've got two options. I've got 2y minus 3 is equal to a positive 4 square roots of 3. And I've got 2y minus 3 is equal to a negative 4 square roots of 3. Add 3 to both sides. And divide everything by 2. Okay. All right, that works. Same thing to the second equation. Add 3 to both sides. And then to isolate the y, I need to divide the entire thing by 2. Okay? For both of these guys, because we're dividing both sides by 2, remember to put the fraction or the division bar over the entire thing, because until I know what this whole numerator is, I cannot divide by 2. I can't just cancel the 4 and the 2 because that leaves out the 3. So I've got to figure out everything for this number and then divide by 2. Similarly here, I got to figure out everything for this number and then divide by 2. Now, every once in a while, you may see this written as y is equal to 3 plus or minus 4 square roots of 3 divided by 2. Because all they've done is they've noticed that this is plus 4 square roots of 3 and this is minus square roots of 3. So they've combined it into one statement as 3 plus 4 square roots of 3 and 3 minus 4 square roots of 3 in order to give you that same sort of feel of two different answers. Okay? How would I check this one? Well, if I'm being honest, I probably don't want to put all of this in for the y. I mean, that's some algebra going on there. Because we can. Because we can. I'm going to pull a little post-it. So if I was going to check this one, right? I want to check y is equal to 3 plus 4 square roots of 3 over 2. So I'm going to take all of this 2y minus 3 squared. And I'm going to put all of that circle in for the y. I know it looks gnarly, but wait till you see the slick of this. Okay, so now we've got a 2. And then we've got, in that orange, right, we have 3 plus 4 square roots of 3 over 2. Minus 3 squared. So I took everything in that orange circle and I put it in where the y was. Here's the beauty of this. This 2 and the 2 in the denominator here will cancel. They cancel out. I don't even have to do the math. It's times 2 divided by 2. They're gone. Canceled out. That leaves me in the parentheses with 3 plus 4 square roots of 3 minus 3 squared. And now we have the same situation we had with the last problem. We have a 3 minus 3. That plus 3 minus 3 will cancel each other out. And now all I have is 4 square roots of 3 squared. If I do 4 squared, that's 16. Square root of 3 squared is 3. So this is 16 times 3, which is 48. And that's what we were meant to get. If I check the negative, right? So now if I'm going to check the negative portion of this, y is equal to 3 minus 4 square roots of 3 over 2. I'm going to put all of that into 2y minus 3 squared. So again, all of this is going to go in where the y was. So this is going to give us a 2. Where the y is, I'm going to put 3 minus 4 square roots of 3 over 2 minus 3 squared. Look at my 2's. It's the same situation from before, right? This 2 and this 2 are going to cancel because that's multiplying by 2, that's dividing by 2. Multiplication and division are inverse operations. They cancel each other out. So in parentheses, I'm now going to have 3 minus 4 square roots of 3 minus 3 squared. This 3 and the minus 3 zero each other out. And we have a negative 4 square root of 3 squared. So I need to square a negative 4. That's 16 times the square root of 3 squared is 3. That's 16 times 3 is 48. So this also checks. I have checked both of the solutions. And I have y is 3 plus 4 square roots of 3 all over 2. And y is equal to 4 minus 3 minus 4 square roots of 3 all over 2. Also written as all one step plus or minus. Okay? All right, what do we got going on next? Oh, okay. These two. We are going to see if you can recognize what's going on with these guys. All right, we want to solve these two using the square root property. Again, we're going to have you check your answers, similar to what we have done. Now, this one is a... Can you see it? Can you see what's going on here? For problem number 11, I have c squared minus 14c plus 49. If they want us to use the square root property, this needs to be a perfect square. C squared minus 14c plus 49. Is that a perfect square trinomial? Well, 49 is 7 squared. Is the middle term double that 7? 14 is 7 squared. So what they're asking you to see here is that c squared minus 14c plus 49 is c minus 7 squared. Is everybody going to catch that right off? Nope. Nope, they're not. It's okay. You might catch it in this homework assignment because you're looking for it, and then you might not catch it in the next homework assignment because you're looking for something else. And you might come back to it 3 days from now and not understand it and need it explained again. And that's okay. These are new concepts to you, all right? We can't remember everything the first time out. But do you understand how I got the c minus 7? That is, if I were to square c minus 7 times c minus 7, I would get the square, the two terms multiplied together and doubled, and the last term squared. Square, multiply, double, square. Square, multiply these two together and double it, and then square the last term to get the 49. Okay? Yeah? Good. Okay. Now what we have is just what we were doing. So we're going to go ahead and take the square root of both sides. Right? This square and the square root leaves us with c minus 7 is equal to a positive negative 5. Positive or negative, oops, I always forget that. Don't forget your square root like I just did. Just don't do it. I need this to be a square root of 5. So this is technically two answers, but, and this is the slick part, what I can do is just add 7 to both sides because I was going to do that anyway. Even when I split them up, I was going to add 7 to both sides. So I have c is equal to 7 plus or minus the square root of 5. You still need to see this as two answers. This could be c is equal to 7 plus the square root of 5, or it could be that c is equal to 7 minus the square root of 5. And if we're checking them, the check is not going to be fun. If we're checking them, we have 7 plus the square root of 5 squared minus 14 times 7 plus square root of 5 plus 49, right? We want to put this 7 plus square root of 5 in wherever we see a c. Okay, so, oh man, what's this going to be? So this is going to be 7 squared, which is 49, plus multiply together and double it. So 7 square roots of 5 doubled is 14 square roots of 5. And then we want to square that last term, which is going to be a 5. Minus 14 times 7. I don't know what that is. So that's where my calculator is going to come in. 14 times 7. I want to say it's 91, but 98. Okay. So this is going to be 98 minus 14 square roots of 5 plus 49. Okay, so 49 and 49, because that drew my eye right away. So 49 times 2 is 98, but I'm subtracting 98, so those three will zero out. And then I have a plus 14 square root of 5 and a minus 14. Those two will zero out. And I'm just left with 5. So it checked. Yes. Okay, now let's try the other one. Okay, so we're going to have a 7 minus square root of 5 squared minus 14 times 7 minus square root of 5 plus 49. Okay, so 7 minus square root of 5 squared is going to be 7 squared. That's 49. Minus, multiply together and double. So that's going to be 14 square roots of 5 and square the last one plus 5. Distribute, minus 14 times 7 we know is a minus 98. Just did that one. Minus 14 times a minus square root of 5 is a plus 14 square root of 5 plus 49. Okay, now what will cancel? The 49 and the 49 again is 98. Minus 98 is zeroing out. Minus 14 square roots of 5 plus 14 square roots of 5 cancel out. And I'm left with just a 5, which was exactly what I was supposed to get. So this is it. C is equal to 7 plus or minus square root of 5. And I have my solutions. Okay. Problem number 12. Same idea. Okay. I wonder if that does the same thing. Is this also a perfect square trinomial? Well, 81 is 9 squared. And if I multiply 9 times a and double it, I do get 18. So what that tells me is this is a plus 9 squared is equal to 12. Taking the square root of both sides, I get a plus 9 is equal to a positive negative square root of 12. Now, the square root of 12 is 2 times 2 times 3. So this is a positive negative 2 square roots of 3 because we do want to simplify it. So a plus 9 is equal to a positive negative 2 square roots of 3. I want to subtract 9 from both sides. A would be a negative 9 plus or minus 2 square root of 3. Beautiful. This is still two answers to check. Negative 9 plus 2 square roots of 3. Which, if I needed a decimal, right? I'm going to clear this out. I'm going to do, we glitched again. There we go. All right, I'm going to do negative 9, clear, negative 9 plus 2 square roots of 3. And that's going to be about negative 5.536. 5.536. Yep. And, or I should say, a could be a negative 9 minus 2 square roots of 3. We're going to do negative 9 minus 2 second square root 3. And that's going to be a negative 12.464. Now, as I said a little bit earlier in this video, some people do like to check the decimals because it works better for them. So I'm going to check the decimals on this. I'm going to put the negative 5.536 in for the A, and I'm looking to get close to 12. The more decimal places you keep on this, the closer you will be to the 12. 5.536 parentheses squared plus 18 times negative 5.536 plus 81. And remember, I want to be close to 12. And look at that, 11.99999. That's basically 12. If I hadn't rounded, I probably would have gotten a 12. But I have to round because they're irrational numbers. They'll go on forever. But it's good to know that I get really close with a rounded number. Okay. So the second one is a negative 12.464. So parentheses, negative 12.464 squared plus 18 times a negative 12.464 plus 81. And again, I also want to get close to 12. Look at that, 11.999 again, which is essentially 12. So both of these guys checked using a calculator. And my value of A is a negative 9 plus or minus 2 square roots of 3. Okay, there was a lot in there. There's a lot of algebra in there. But of course, we've got to do a couple of applications. I would say that the lucky part of these applications is that the algebra is a lot easier. The setup still might be a little bit tough, but all right, so goal number 3 is to solve some problems that are modeled using quadratic equations. That's degree 2. Pro wrestling requires a square ring with an area of 400 square feet. Find the length of a side of the ring. A square with an area of 400 feet. So I'm going to go ahead and draw a square. We know that the area is 400 square feet. We know that the area for a square, well, if it's a square, right? And they do say it's a square ring. So it is a square. So whatever this side is, the area is x times x. Oh, man. Since these are the area of the same thing, we do know that x squared would have to be 400. Using what we learned in the very beginning, I can take the square root of both sides. So the square root of x squared has to equal the square root of 400. And x would be a positive or negative 20. Since we're talking about the length of a side, the length cannot be negative. Length is not directional. It is just the positive. So the x value that will work here is a positive 20 feet. We have to eliminate the negative. Not because it doesn't work in the equation, but because it would not work in the application. We don't measure length as a negative value. So our x value would be the positive 20 feet. Does that seem a little bit too easy? Yeah. Don't overthink some of these. That's the best advice I got for you. All right, the formula D is equal to 16t squared represents the distance d in feet that an object falls in t seconds. The tallest building in the world is the Burj Khalifa at 2,770 feet tall. If an apple is dropped from a platform 29 feet below the top, how long will it take to hit the ground? So how long means we're finding t. The distance is going to be the 27,117 minus the 29 feet from the top. Right? Because we're not all the way at the top, so 29 feet from the top, so 2717 minus 29 is 2688.